Okay guys, for mini quiz number 5, I thought it'd be fun to let you guys try to grade your own just a little bit. So, got all the answers here for you. I'm still going to walk you through all the problems, but thought you guys might benefit from going through those scoring standards on your own. So your 4 multiple choice answers are D, 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 and A. Let's walk through and see what's going on. In this first problem here, where I forgot to include number 1 here, they've given us a table of values, tell us our function is continuous on a closed interval, and that we've got a trapezoidal approximation for the integral underneath this function on that interval from 0 to 6, and they tell us the value of that trapezoidal approximation is 52, and they want to know what's the value of this k right over here. Okay, so what we're doing here, guys, is our approximation here of 3 trapezoids. And this is one where you could go ahead and do some factoring because all of the trapezoids have the same height. They do tell us right there that we've got subintervals of equal length. But honestly, where most of us are getting into trouble at this point is we're assuming that's the case even when it's not. So I'm going to keep it simpler and just do one trapezoid at a time. First trapezoid, its area is going to be 1/2 times a height here, that being the distance between its x values of 0 and 2. So it has a height of 2, and then the sum of its bases are going to be 4 and k, so we're going to write that as a k plus 4. And that is the area of the first trapezoid. Second one, 1/2 times a height. Now this time we're going from 2 to 4, which again is still a height of 2, and adding together its bases, that's going to get us a k plus 8. That's the second trapezoid. And the third one is going to be a 1/2. Now from 4 to 6 is again a height of 2, and then adding the two bases together, that's going to be an 8 plus a 12. And they told us now that the value of that trapezoidal approximation is 52. So that's going to go right here. And let's see what we can do to solve for k. Now, the one break they cut us right here, guys, is the fact that in every one of these 3 trapezoids, the height is 2. So when we multiply that 2 by the 1/2 out in front, well, that just makes a big factor of 1 that we can then kind of ignore. So basically, we're just adding together all of the heights. We've got a k here and a k here from each of the first 2 trapezoids, so that's 2k. And then adding our constants, we have a 4 plus 8, which is 12. The 8 and the 12 is going to make a 20, so the 12 and the 20 makes a 32. Subtract the 32 from both sides, and we're going to get a 2k equals 20, and k is equal to 10. So our answer for number 1 is D. Let's take a look at problem number 2. For a function f, they've given us f prime, all right, explicit definition of the derivative of that function, but also then the value of f at a particular x value, which is 1. They want an approximation for f of 1.2 found by using the line tangent to the graph at that particular spot. Okay, so this is a linearization problem, and if you recall, what we're going to need here is the equation of our tangent. Well, we know that our point of tangency is given to us by this ordered pair right here, so that's going to be 1, 4. The only other thing we need is the slope of that tangent. The slope of the tangent always comes from our derivative, f prime, evaluated at the x value of the point of tangency. So we need f prime of 1. And going back to this function right here, 2 times 1 plus 1 is going to be 3. So now we know our point of tangency, we know the slope of our tangent, and we're going to write the equation of that tangent line. It's going to be a y minus 4 equals our slope of 3 times x minus 1. And usually then we like to solve that for y. And that's going to give us, this isn't too hard to do by hand here, the 3 times x is going to be a 3x, would have been a minus 3, but we'd add that 4 to it, and we get y equals 3x plus 1 now for the equation of the tangent line. And they want an approximation for f of 1.2. So if you recall, f of 1.2 is approximately equal to L of 1.2. L of 1.2 is the linearization of this function at that point, and this function that we just came up with right here, the equation of our tangent, that's our linearization function. So we're just going to plug a 1.2 into this expression right here. 3 times a 1.2 plus 1. Well, it's going to get us a 3.6 plus 1 is going to get us 4.6 for our approximation here for f of 1.2. So it looks like our answer here for number 2 is going to be D also. Okay, let's move on to number 3. Remember, these are calculator questions. Not sure if we're going to need them or not. This one, I don't think we're going to need it. Let's take a look at what's going on. They've given us the value of the integral from 0 to 3 of f of x and an integral from 3 to 5 of the same function. Now they want to know what's the value of the integral going from 0 to 5 of 3 plus 2f of x, all taken with respect to x. Okay, so what we're looking for is this integral right here of 3 plus 2f of x and a dx. And what I think we want to do right here is take advantage of the fact that we've got two different things being added together within our integrand. We can split this up into two integrals. An integral from 0 to 5 of 3 with respect to x, plus an integral from 0 to 5 of 2f of x dx. Well, I'm going to pull that 2 out in front because it's a constant, and just keep the f of x dx right there. And this expression here should get us the answer. Okay, guys, first part should be pretty easy. We're doing a definite integral of a constant function. This is just a rectangle. From 0 to 5 is a width of 5. Our height is 3. That first integral right there is going to equal 15. On to the second part now. This is going to be a plus 2, and what I think you guys probably figured out already, the integral from 0 to 5 of f of x is just going to be the sum of these two integrals right here. We're going to put the 6 and the 4 together using the additivity property and get a 10 right there. So that 2 times 10 is going to get us a 20 plus 15 is going to be 35, and the answer to number 3 is D as well. And let's take a look at number 4. And now with all of these messy decimals here, I got a feeling we are going to need a calculator here. But let's see what's going on. A spherical tank contains 81.637 gallons of water at t equals 0 minutes. Hey everybody, that is what we call an initial condition. And I'd be willing to bet right now that whatever the right answer to this question is, if you subtracted 81.637 from the right answer, I'm thinking that is going to be one of the answers here. Boy, as I'm looking at them real quick, that really makes me think, well, I think I'm wrong here, by the way. I really would have guessed that the answer was E, but I'm pretty sure it's not as I look at it now. But anyway, let's stop thinking, Mr. Fontana, and just do the problem. For the next 6 minutes, water flows out of a tank given by this function right here. How many gallons of water are in the tank at the end of the 6 minutes? Okay, so if we want to know the volume of water in the tank 6 minutes in, the first thing we have to do is think about the initial amount, which was 81.637. So we're starting from there. This kind of reads like an input-output question. But the only thing they're giving us right here is an output flow rate here in gallons per minute. It says nothing about input, so we are only going to be subtracting from this. And the input rate was given in gallons per minute. We need to get that to gallons. So this is going to be a definite integral now, starting at 0 minutes and ending at 6 of that output rate function, which was 9 times the sine of the square root of t plus 1. And like an idiot, I wrote right over that. I got to see, yeah, that square root goes over the entire quantity of t plus 1 and a dt at the end of all that. So we got to make sure that we watch out for that. Okay, so this should be a pretty straightforward calculation right here. Okay, where did I put all my stuff here? I got to remember where everything is here, guys. Okay, let's go here, and oops, I do not have my Inspire app on here. Do I? Sorry, guys. Nope, I don't think it's on there yet. Okay, let me do this on my computer here. You guys can just bear with me for a second. All right, so what are we typing in here? 81.637 minus and an integral. So menu 43, an integral starting at 0, ending at 6, and the function, the integrand here, was going to be a 9 times the sine of the square root of t plus 1. Okay, and we're integrating all that with respect to t. All right, I think we've got everything in there, guys. I came up with an answer of 36.606. Okay, and that looks like A is the correct answer. Back to when I said that I thought the answer was E, it turns out I went the wrong way with this one right here. Because the function they gave us was the output function, the common mistake would have been for people to forget the 81.637, which actually would have made the answer 81.637 more than the correct answer. So if I took the answer and added the 81.637 to it, we end up with 118. No, that wasn't it either there, guys. 118.242 was not one of the choices. Oh, well, don't worry about it. A is the correct answer. Okay, let's move on to the free response question here and see what's going on with this one. All right, guys. So what do we have here? We've got a function. Very important to understand. We are looking at the graph of f prime, not the graph of f right here. As I'm grading a lot of your work here, guys, with mini quizzes, with homework assignments, with the final exam, things like that, we've got to pay attention, because we're having some trouble with this. We've got to pay attention to what function it is that we're looking at, and we've got to use the name of that function when we are referencing it. We can't say ambiguous words like it or the function or the graph. We want to be specific and call this thing by name, that being f prime. So, reading the problem here, f is a twice differentiable function, so both its first and second derivatives always exist on the interval from negative 1.2 to 3.2. This looks like an initial condition right here of f of 1 equals 2, probably important. They've given us the graph of f prime, crosses the x-axis like we probably would have assumed here at negative 1 and again at 3. And we have a horizontal tangent right here at 2. So again, they don't want to leave anything to chance or assumption here. We know that we've got a horizontal tangent line at that spot right there. And here we go. Let g be the function given by, and we've got an explicit definition of g of x being e to the f of x. Interesting. So again, one function being defined in terms of the other. Okay, so part A, write an equation for the line tangent to the graph of g at x equals 1. Okay, well, kind of like we did on problem number 2, I think, a while ago, the multiple choice, if we need a tangent line, we need to know two things. All right, we need to know the point of tangency, and we need to know the slope of our tangent. So first thing we need to do right here is figure out the value of g of 1 to get that point of tangency. Well, g of x was defined for us as e to the f of x power. So that's going to be e to the f of 1, and we've got to figure out what that is. So the value of f of 1 is going to come from, let's take a look. Oh, this function right over here, they told us right there that f of 1 was equal to 2. So that becomes e to the second power, and that's as much as I'm going to do with that, guys. I'm going to leave g of 1 as e squared. So that tells us that our point of tangency is going to be the ordered pair 1 and then e squared. The second thing we need is the slope of our tangent. And the slope of the tangent comes from the derivative of g. So we need g prime of x. Okay, so the function g was defined right here by e to the f of x. We need to take the derivative of that. Well, the derivative of e to any power is going to be the same base to the same power, f of x, multiplied by the derivative of that exponent right there. So the derivative of our exponent is simply going to be f prime of x. Okay, so that's it for g prime of x, but we now need to evaluate that at the point of tangency. That's g prime of 1. So the first thing we need right here is the value of f prime of 1, and that's going to come from this equation right over here, and we can see that when x is 1, they tell us explicitly, no assuming, that the value of that function right there is negative 4. So f prime of 1 is negative 4. That's going to go right here. That's going to get multiplied now by e to the first power, which is e to the f of 1, which we just came up with a second ago. That is going to be e squared, same value that we came up here. So that tells us now, guys, that the slope of our tangent is going to equal a negative 4 e squared. And now that we know our point of tangency and our slope right here, we can come up with the equation of our tangent line. That's going to be a y minus e squared is equal to our slope, which is a negative 4e squared times the quantity of x minus 1. Now, technically, you'd be able to quit right there and get full credit for your answer here. They didn't specify what form they wanted it in, but since we want to check our answer, I'm pretty darn sure they went ahead and put this thing into slope-intercept. So I'm going to distribute that here on this right side and get a negative 4. Let's see, I'm actually going to make that a negative 4, then an e squared multiplied by an x, and then we've got a plus 4 e squared at the end of that. We're going to take this negative e squared and add it to the other side. So we're going to get y is equal to a negative 4 e squared times x, and then adding that should get us a plus 5 e squared. And that should get us the equation of that tangent line. I want to check that one before we move on anywhere, guys, and make sure that we got A right. Okay, they left theirs in point slope equation. The e squared minus 4, yeah, I think that's the same thing that we've got right there. Okay. So let's see, that took care of part A. Let's move on to part B. Okay, in between the x values of negative 1.2 and 3.2, we need to find all values of x at which g has a local maximum, and we need to justify that answer. So again, I like to start off with the explanation right there. G has a local maximum where, and this is universally true now for all functions, its derivative changes from positive to negative. But I don't just want to say it. The derivative of g has a name, and that would be g prime of x changes to, let's do that there. G prime of x changes sign, and we should be specific because we're talking about a maximum now, from positive to negative. Okay, so we've got to do a little bit of work on g prime of x. Now, as we wrote down in the last problem here, g prime of x doesn't get much cleaner than this expression right over there. F prime of x times e to the f of x. So let's write that down again. G prime of x is equal to f prime of x multiplied by e to the f of x power. And if we want to know where this thing changes sign, we would set it equal to 0 and try to solve. Now we have a factored expression here. The first factor is f prime of x. The second factor is e to the f of x. Any value of x that makes either one of these two factors equal 0 is going to give us a solution to this equation. But the nice thing is, and this certainly shows up a lot, e to a power, guys, is never going to equal 0. It's impossible. So the only way we can do this is if f prime of x is equal to 0, and I do believe they told us back in the original problem right here that the graph of, oh, where did we go right here, everybody? Hang on just a second. Yep, f prime of x, there we go. That this graph of f prime of x equals 0 twice, at negative 1 and at positive 3. So that happens at x equals negative 1 or at x equals positive 3. Make sure I've got that right. Negative 1, positive 3. Okay, so these become the two spots right here, everybody, where this function has the potential for a local maximum. So if we wanted to be thorough about this, yeah, let's run with that. We could probably get away without this right here. Specifically, I think we could talk about sign changes right here. At negative 1, what's going on right here, guys? The value of f prime is specifically changing sign from positive, being above the x-axis, down to negative right there. And at a spot where f prime right here goes from positive to negative, we know that e to a power is always going to be positive. This is our one spot right over here where we could have a local maximum. Right here at x equals 3, what happens is that the sign of f prime changes from negative to positive. This is a spot right here where we would have a local minimum because our derivative goes from negative to positive, or the function goes from decreasing to increasing. So find all values at which g has a local max and justify our answer. So I think we can say right here that g of x has a local max at x equals negative 1 because, sorry guys, cram that in there, because what can we say now? G prime of x changes from positive to negative at this spot only. X equals negative 1 only, and we'll cram that one in there. Okay, so that takes care of part B. Again, let's double check that, guys. Make sure we got that right. G prime changes from positive to negative only at x equals negative 1. Okay, so a little messy, but there it is. Let's move on to part C here. Second derivative of g, they gave it to you, so that was nice. They didn't make us do the work on that, and they want us to find out whether g prime of negative 1 is positive, negative, or 0. Interesting. So they actually gave you the explicit definition, so let's check it out. G double prime of negative 1 then is going to equal, so we've got e to the f of negative 1 We'll worry about that in a minute. Then starting a set of brackets. And then in parentheses right here, we've got f prime of negative 1. Close all that and square that, plus f double prime of negative 1. Okay, and we've got to try to figure out the value of all of this. So let's see what's going on here, guys. E to the f of negative 1. Let's start with that. All right, so f of negative 1... Yep, sorry. All right, did we do f of negative 1? I thought we did at some point right here. F of negative 1. Oh, that was given to us. No, that's f of positive 1. All right, so we're looking for the value right here of f of negative 1, and I'm not seeing that just yet. Have we found that? Derivative of f is shown. Sometimes that was a value we came up with earlier that we may have forgotten about. I don't think it was in part A. I don't think it was in part B. Oh, okay, actually, now that I look at it, I don't think it matters too much. They weren't asking us for the value of g prime of negative 1, just the sign. Is it positive, negative, or 0? So since e to the f of negative 1 is being multiplied by everything else, we know that the sign of this number right here, e to any power, is always going to be positive. So I'm just going to very generically put a plus sign right there, and that means that whatever we come up with inside the brackets should be okay. All right, f prime of negative 1. Here's f prime, and f prime at negative 1 was going to equal 0 because of this point right over here. So the f prime of negative 1 becomes a 0, and I guess we need to square that, sure, plus an f double prime of negative 1. Okay, so again, I don't think the value here matters too much because of the 0 that we got here. I think it's just the sign. F double prime of negative 1. Well, they gave us information about f prime. The derivative of this graph is f double prime, and that sign can be found by looking at the behavior of this function right over here. And what we can see is that f prime is decreasing at negative 1. A function that is decreasing has a negative derivative. So that means that our derivative right over here of f prime at negative 1 is going to be something negative. So boy, this is a little bit odd here, guys, but we end up with a positive number, let's put that in parentheses again, multiplied by 0 plus a negative number is going to be a negative number, and that means that this value right here, g double prime of negative 1, is negative. And I believe that the work that we just provided up above right there is going to be sufficient for a justification. All right, so let's take a look at their answer for part C. I think they've got, yeah, that's positive. We know that's 0. Okay, I think we've got it right there, so that value is going to be negative as well. Okay, so we got that. And let's move on to the last part right here. Find the average rate of change of g prime, the derivative of g, over the interval from 1 to 3. Now, I am seeing some people run into some trouble here once in a while, confusing the concepts of average rate of change with the formula for average value of a function. So we've got to remember which one is which. The formula for average rate of change of a function is simpler than the one for average value. It's just going to be f of b minus f of a all over b minus a. It's basically just going to be change in y over change in x. The tricky part right here, guys, is that we've got to try to remember here that we're doing the average rate of change of g prime, not the average rate of change of x. So to write this a different way here, we're doing g prime evaluated at b, which is 3, minus g prime evaluated at a, which is 1, all over the change in your x values, which is going to be a 3 minus 1. All right, and let's see what we've got right here. So g prime of 3. Have we found that particular value yet? We've got the equation for g. We know that g prime right over here is this expression. But I don't think we've actually evaluated that just yet. We do know the value of g prime of 1, and I think we're going to need that in just a second, but I don't think we have found g prime of 3 yet. So let me take just a second and write this out one more time, that g prime of x, I better go back and double check this, but I believe it was f prime of x multiplied by e to the f of x. Let's go back and look at that again. G prime of x was equal to f prime of x times e to the f of x. Yep, and that's what we wrote down there. Okay, so for g prime of 3, we are going to need f prime of 3 got it, multiplied by e to the f of 3 power. Minus, and here we go. Now the fun part about this is we already found the value of g prime of 1, and that was right here. G prime of 1 was given to us by, yeah, that expression right there. There wasn't much to do with it. Negative 4e squared. So minus a negative 4e squared for the value of g prime of negative 1 all over a 2 on the bottom. Okay, let's see what's going on the top here. F, that's an ugly prime, Mr. Fontana, but f prime of 3. Okay, going back to this function right here, this is the graph of f prime, and f prime of 3 was a big fat 0. So that first term just got easier, guys. This is 0 times something, and it doesn't matter. That's just going to be 0. Plus a 4e squared all over 2. Oh, not as bad as I thought then, guys. Forget about that. Divide by the 2, and that should get us a 2e squared now for the average rate of change of g prime on that interval right there. So let's double check that one as well. 2e squared, that's what we were looking for. Okay, so that's how we work out all 4 parts here. I will scroll through the 4 answers so you guys can pause the video and check to see it as you need it for the scoring standard. So there's part A. There's B, 2 points for that one. 2 points awarded here for part C. 1 for getting the answer right and 1 for the justification. And then 2 points awarded here for part D. 1 for setting up the difference quotient and then 1 for getting the answer. And let's look at this again too. This isn't exactly the key that I've been following for these mini quizzes, but for now I think it's close enough. So let's just say for the sake of argument here, guys, that on multiple choice you got 2 right, and on free response out of the 9 you did pretty well, and you got 5 right there. Okay, that means that you're a 2 for multiple choice now. You're a 5 for free response. So if we move over here and down here, hey, that means that you got a 4 on this particular mini quiz right there. So, okay, hopefully you guys can figure out how you did. If you have any questions, post them in comments, and we'll see if we can't work them out in greater detail.